everything you know is temporary. Not just life, not just Earth, not even stars. Galaxies will fade, atoms will drift apart, even time itself may lose meaning at the end of everything. Right now, the universe feels alive. It expands, it moves, it changes. Stars are born in glowing clouds of gas. Black holes consume entire systems. Light travels across billions of years just to reach your eyes. But hidden inside this cosmic activity is something deeply unsettling. The universe is slowly running out of ways to stay active. And this leads to a question that goes far beyond science fiction. If the universe keeps expanding forever, stretching farther and colder with every passing moment, then what is the final state of reality itself? Not just the end of stars, not just the end of galaxies, the final condition of everything that exists. There is a possibility that the universe does not end in destruction. It does not collapse. It does not explode. Instead, it fades slowly, quietly, until nothing new can ever happen again. Most people never hear about this idea in detail. It is not about dramatic cosmic disasters. It is about something far more silent and far more permanent. A future where energy becomes so spread out that nothing in existence can use it anymore. This concept comes from modern cosmology and is based on real physics, not speculation. Scientists studying the universe today are not just asking how it began. They are also asking how it will end. And the answers are not comforting. One of the leading voices in this field is cosmologist Brian Greene, known for his work on space-time, string theory, and the deep structure of reality. His explanations of entropy and the fate of the cosmos help reveal a future where the universe does not collapse into darkness suddenly. Instead, it slowly loses the ability to create anything new at all. At the center of this idea is energy. Everything in the universe depends on usable energy. Stars burn because energy is concentrated. Planets move because energy is transferred. Life exists because energy flows in organized ways. Even time, as we experience it, is tied to change driven by energy. But energy does not stay organized forever. Over time, it spreads out. It becomes more uniform, less useful, less powerful. This process is not random. It follows a fundamental rule of physics called entropy, which always increases in an isolated system. As entropy grows, the universe becomes less capable of change. That means fewer stars forming, fewer reactions happening, fewer events that create structure or order. At some point in this process, something critical happens. The universe reaches a state where there are no longer any meaningful energy differences left. No hot and cold regions, no concentrated sources of power, no gradients to drive motion or transformation. When that happens, the engine of change shuts down. This video will take you through that entire journey. From the current active universe we live in today, all the way to its final possible state. A state where galaxies drift so far apart that they can no longer see each other. Where stars burn out one by one. Where even black holes, the most extreme objects in existence, slowly evaporate over unimaginable timescales. And then beyond that, a phase where even matter itself may become unstable. Where particles drift alone in a dark, expanding space. Where energy is so diluted that it cannot power anything at all. There is a lesser-known idea hidden inside this story. The universe may not end with a final dramatic event. There may be no final explosion, no final collapse, no final moment of destruction. Instead, there may simply be a gradual loss of activity until reality becomes almost unrecognizable compared to what it is today. This is often described as the slow fade of the cosmos, a transition from a universe full of structure and motion to a universe that is cold, empty, and static, not because something breaks, but because everything possible has already happened. And here's the part that most people do not realize. Even when stars die and galaxies disappear from view, the universe does not immediately become lifeless. It continues for trillions upon trillions of years. Long after the last star fades, there will still be remnants. White dwarfs cooling down, neutron stars drifting silently, black holes slowly shrinking over time, but even these final giants are not permanent. Physics suggests that black holes themselves may eventually lose energy and evaporate through a process known as Hawking radiation. Over extremely long timescales, even the most massive objects in the universe may disappear completely. After that, what remains is not destruction. It is absence of change. This raises a deeper question that runs through all of modern cosmology. If nothing can change, does time still have meaning? If no energy can be used, does motion still exist in any form? Or does reality itself become something completely different from what we understand today? These are the questions at the heart of this video. We will explore how the universe evolves from its current energetic state into its final possible condition. We will follow the path of stars, black holes, entropy, and space-time itself. And we will uncover why many physicists believe the universe may not end with a sudden event, but with a slow fading into near nothingness. Stay until the end, because the final stage of the universe challenges everything we assume about existence itself. Welcome to the channel. If you are interested in the deepest mysteries of space, time, and reality, subscribe now. The universe is not only expanding, it is accelerating as it expands. This is one of the most surprising discoveries in modern cosmology. For a long time, scientists believed gravity might slow the expansion down. Instead, something else is pushing everything apart faster and faster. This unknown force is called dark energy. It does not glow. It does not shine. It does not interact with light. Yet it makes up most of the universe, and effect is simple but powerful. Space itself is stretching, and everything inside it is being carried away from everything else. Galaxies are not flying through space away from each other like explosions. Instead, space itself is expanding between them. This is an important difference. It means that even if galaxies are not moving locally, the distance between them still grows. Over time, this creates a universe where distant galaxies become harder and harder to see. There is a lesser known consequence of this process. As space expands, energy becomes more spread out. In physics, this is called dilution. The same amount of energy is now stretched across a larger volume. That means it becomes weaker, less concentrated, less able to do work. In the early universe, energy was packed tightly. This allowed matter to form quickly. Stars ignited from dense clouds of gas. Galaxies formed under strong gravitational pull. Structure appeared because energy differences were sharp and powerful. But as expansion continues, those differences begin to weaken. Gravity still works, but it has to compete with the stretching of space. Over long periods of time, this changes everything. One of the most important effects of this slow expansion is what happens to star formation. Stars are born when clouds of gas collapse under their own gravity. But for that collapse to happen, the gas must be dense enough. It must be close enough. It must be able to gather itself. As galaxies drift farther apart and matter becomes more spread out, these conditions become harder to meet. Gas clouds thin out. Gravity has less material to work with. Eventually, regions that once formed stars easily can no longer do so. This process does not happen quickly. It unfolds over billions and trillions of years. But the direction is one way. Fewer stars are formed over time. Older stars continue to burn, but no new generations replace them at the same rate. There is a hidden detail in this expansion that is often overlooked. It does not just separate galaxies. It also stretches the space between particles inside galaxies. On extremely large timescales, even the environments needed for star formation inside galaxies begin to fail. As this continues, the universe slowly loses one of its most fundamental abilities. the ability to create new structure from simple matter. No new stars, no new bright regions, no fresh systems forming from cosmic dust. The universe remains active, but less and less so. It continues to expand, but every step forward makes it more difficult for complexity to arise again. Stars are not permanent. They are temporary engines that turn gas into light. Every star in the universe has a lifespan. Some live fast and die young. Others burn slowly for trillions of years. But none of them last forever. The process of star formation depends on one fragile condition. Dense clouds of gas must collapse under gravity. When that collapse happens, pressure rises in the center until nuclear fusion begins. A new star is born, releasing energy as light and heat. But as time moves forward, those gas clouds do not last. They are slowly used up. Some are locked into planets. Some are blown away by radiation from nearby stars. Some drift too far apart to collapse again. Over extremely long periods, the raw material for new stars becomes rare. There is a lesser-known detail in this process. Even galaxies that still contain gas do not always form stars efficiently. As the universe expands and cools, the average temperature of space drops. Cold gas can exist without collapsing. It becomes stable, spread out, and inactive. This means that even when material is present, it may not participate in star formation anymore. As a result, star birth begins to slow down. Then it stops completely. But stars that already exist continue their life cycles. They burn hydrogen in their cores, producing light for millions or billions of years. Some stars swell into red giants before shedding their outer layers. Others explode in supernova events, briefly outshining entire galaxies. After these final bursts of energy, what remains is even more important for the long future of the universe. White dwarfs form from smaller stars. They are dense, hot remnants that slowly cool over time. Neutron stars form from massive stars that collapsed under extreme gravity. They are incredibly dense, with matter packed tighter than anything else known. Black holes form when even that collapse goes further, creating regions where gravity becomes extreme. These are the final remnants of stellar evolution. They do not shine in the same way stars do. They do not produce new energy through fusion. They are the leftover structures of a universe that once burned brightly. There is a dramatic shift happening here that is easy to miss. The universe is moving from a state where energy is constantly being created and released to a state where energy is only being stored and slowly lost. No new fusion reactions are happening once star formation ends. That means no new sources of sustained light, no new long-term energy engines. The cosmic supply of illumination is no longer being replenished. Even the brightest objects left behind begin to fade. White dwarfs cool and dim. Neutron stars slowly lose rotational energy. Black holes remain, but they do not emit light in the traditional sense. As more time passes, the universe changes character. It is no longer filled with active, shining systems. It becomes a place where the remaining light is only the echo of a younger cosmos. The brightness that once filled galaxies becomes rare, scattered, and temporary. After the last stars die, the universe does not become empty right away. Something even more extreme takes over: black holes. These objects are the final stage of gravity's power. When massive stars collapse, they leave behind regions where matter is crushed into a point of extreme density. Not even light can escape once it crosses the boundary. This boundary is called the event horizon. At this stage of the universe, black holes begin to dominate. They remain long after stars fade. They merge with each other. They grow larger. Some become supermassive, sitting at the centers of galaxies, holding everything around them in gravitational control. There is a lesser-known fact about black holes that changes everything about their future. They are not truly eternal. They slowly lose energy. This process is called Hawking radiation, named after physicist Stephen Hawking. It comes from quantum effects near the event horizon. Particles and radiation slowly leak away from the black hole. Over unimaginable timescales, this causes even the largest black holes to shrink. The timescale is so extreme that it is hard to compare to anything in human experience. A black hole with the mass of a star can take far longer than the current age of the universe to noticeably change. Supermassive black holes can take far longer than that. But the direction is always the same. They lose energy, slowly, steadily, without stopping. As black holes begin to dominate the universe, they become the main remaining engines of gravity and structure. Everything else has already faded. No new stars are forming. No new light sources exist. Black holes are the last major objects shaping space-time, but even this stage is temporary. As black holes evaporate, they release small amounts of radiation. This is extremely weak compared to the energy they once held. Over time, they shrink, then they disappear completely. Once that happens, there is no longer any large-scale structure left in the universe. No stars, no planets, no galaxies, no black holes. What remains is matter that is no longer organized into systems. Particles drift far apart. Collisions become extremely rare. Interactions become nearly impossible. This is where another dramatic shift happens. Energy is no longer concentrated anywhere in meaningful amounts. Without concentration, there is nothing to drive change, no processes to power motion, no cycles to create structure. The universe begins to feel less like a place filled with objects and more like a vast, expanding emptiness where nothing meaningful occurs. There is an important detail hidden in this stage. Even though black holes fade, the space around them does not return to a previous state. It continues expanding. It continues stretching everything apart. Any remaining particles are carried farther away from each other, reducing the chance of interaction even more. Over immense periods of time, matter becomes increasingly isolated. Single particles drift alone across enormous distances. They are no longer part of stars, planets, or galaxies. They exist, but they are separated by space so large that connection becomes almost impossible. As this continues, the universe becomes colder, not just in temperature, but in activity. Heat is no longer shared between systems. Energy is no longer transferred in meaningful ways. Black holes, once the most powerful objects in existence, become silent, then they vanish. And after them, there is nothing left that can shape the universe in any active way. After black holes disappear, the universe enters a stage where nothing large remains to shape its structure. But something deeper continues in the background, a quiet rule that never stops working: entropy. Entropy is a measure of disorder. It always increases in a closed system. It never goes backward. It only moves forward. This is one of the most important laws in physics because it defines the direction of time itself. In the early universe, entropy was low. Energy was tightly packed. There were strong differences between hot and cold regions, dense and empty regions, active and quiet regions. These differences created motion. They created change. They allowed structure to form. But over time, every process in the universe pushes entropy higher. Stars burn fuel and release heat. Galaxies spread energy across space. Black holes absorb matter and slowly release it again. Each step moves energy toward a more uniform state. There is a lesser-known consequence of this process. It is not just that energy spreads out. It becomes evenly distributed across everything. No region has significantly more energy than another. No system holds a clear advantage that can drive change. When that happens, physics reaches a critical limit. Without differences in temperature, nothing can move in a meaningful way. Heat always flows from hot to cold. But if everything is the same temperature, there is no direction for heat to flow. This final condition is known as heat death. At this stage, the universe is not destroyed. It is not collapsed. It still exists. Space is still there. Particles are still there. Even radiation may still exist in extremely low levels. but everything is spread out evenly. No gradients remain. No energy differences remain. No usable energy remains. There is a subtle detail in this state that makes it even more unsettling. Physics suggests that time itself does not stop. Clocks could still tick in theory. Particles could still exist in motion. But there is no process that creates meaningful change. Nothing grows. Nothing decays in a noticeable way. Nothing interacts in a way that produces new structure. The universe becomes a place of perfect balance, but also complete inactivity. In this state, even random motion becomes rare. Particles are so far apart that collisions are almost impossible. Space continues to expand, making interactions even less likely over time. There is no direction left for physical systems to evolve toward. Every possible process that increases order or creates energy differences has already happened. What remains is a universe where all potential has already been used. Entropy has reached its maximum level, not suddenly, but through an endless accumulation of small changes over unimaginable timescales. At this point, the universe is still present, but it no longer has the ability to support events that we would normally recognize as activity. Everything becomes uniform. Everything becomes still in a physical sense, even if time continues to exist in the background. After entropy reaches its highest possible level, the universe does not suddenly end. It continues, but everything inside it changes character. Matter itself begins to lose meaning as a structured system. Over extremely long timescales, all remaining matter becomes unstable or isolated. Protons may eventually decay according to some theoretical models. Even if that process takes longer than anything we can compare it to, the result is the same. Solid objects slowly lose their structure at the most fundamental level. What remains are particles drifting through an expanding void. They are no longer part of stars. They are no longer part of planets. They are no longer part of galaxies. They exist alone, separated by distances so large that interaction becomes almost impossible. There is a lesser-known detail in this stage of the universe. Even radiation, which once filled space, becomes extremely stretched out by expansion. Light loses energy as it travels across the expanding universe. Its wavelength grows longer. Its effect becomes weaker. Eventually, it becomes so diluted that it no longer plays any meaningful role in physical processes. The universe becomes a place of near total darkness, not because light disappears instantly, but because it becomes too spread out to matter. As time continues, even the simplest interactions become rare events. Particles may drift for trillions upon trillions of years without ever colliding with anything else. The universe becomes so large and empty that probability itself loses practical meaning. There is another subtle transformation happening at this stage. The rules of physics do not stop working, but there is nothing left to apply them to in any meaningful way. Forces still exist. Gravity still exists. Electromagnetism still exists. But there are no structured systems left for these forces to shape. Space-time continues to expand. It still stretches. It still defines distance. It still allows for positions and motion in theory. But without matter organized into systems, space-time becomes a kind of silent framework with nothing active inside it. Even black holes, once the most dominant structures in the universe, are gone. Stars are gone. Galaxies are gone. Even atoms as stable systems are no longer present in large organized forms. What remains is a universe filled with extremely low energy particles scattered across an ever-growing void. Each particle is separated by distances so vast that they effectively exist in isolation. At this stage, change itself begins to lose meaning, not because time has stopped, but because nothing in the universe can undergo a process that creates observable difference. There are no cycles, no reactions, no transformations. Physics still describes equations. It still defines relationships between energy, space, and time. But those equations no longer describe a dynamic reality. They describe a static condition with no active evolution. The universe becomes a system where motion exists only in the most minimal and isolated sense, without interaction or consequence. Everything continues in a form that no longer produces events, no longer creates structure, and no longer leads to anything new. The universe does not seem to end in a single moment. There is no final explosion. There is no sudden collapse. Instead, everything moves in one direction over time, toward less energy, less structure, less change. What begins as a universe full of light, motion, and complexity slowly becomes something very different. Stars burn out, galaxies drift apart, black holes evaporate, even atoms lose their ability to stay organized. Step by step, the engine of change weakens. At first, the universe is dynamic. New stars form, energy flows, structures grow and collide. But as expansion continues and entropy rises, that activity fades. The universe shifts from creation to preservation, then from preservation to silence. Eventually, even preservation ends. What remains is a reality where energy is so spread out that nothing can use it. No system can form. No process can continue. No interaction leads to anything new. This final stage is often called heat death. It is not a dramatic ending. It is the absence of endings in the usual sense. Time may still pass, but nothing meaningful changes within it. The universe becomes static in behavior, even if space and time still exist in the background. This outcome is based on the best current understanding of physics, especially models involving expansion, dark energy, and entropy. But there is still uncertainty. New discoveries could change parts of this picture. The universe still holds unknowns that science continues to explore. Even so, the direction revealed by current theory is clear. The universe does not need a violent collapse to reach an end state. It can simply run out of usable energy. It can gradually lose the ability to support anything new until only emptiness and uniformity remain. There is something deeply unsettling in that idea. Not an end that happens suddenly, but a fading that stretches across unimaginable time. A slow loss of possibility itself. The universe may not die in a moment. It may fade until there is nothing left that can happen at all. If you found this exploration of the future of the cosmos interesting, like the video, and subscribe to the channel, there is much more to uncover about space, time, and the hidden rules that shape reality.